Now we're going to do some calculus. We're going to talk about the continuity and differentiability of inverse functions. So if we let f be a function whose domain is an interval I, if f has an inverse function, then the following statements have to be true. Number one, if f is continuous on its domain, then f inverse is continuous on its domain. If f is increasing on its domain, then f inverse is also increasing on its domain. You can go back and look and see that from the previous examples that we graphed. They all illustrate that. One thing that is important to note is when it says on its domain, f is continuous on the domain of f, f inverse is continuous on the domain of f inverse. So it doesn't have to necessarily be continuous on the same domain, just on its domain. If f is decreasing on its domain, then f inverse is decreasing on its own domain. And if f is differentiable at an interval containing c, and f prime of c is not equal to 0, then f inverse is differentiable at f of c. So f inverse will be differentiable at the y value of f of c, and that makes sense because you swap the ordered pairs. So the next theorem says let f be a function that's differentiable on an interval I. If f has an inverse function g, then g is differentiable at any x for which f prime of g of x is not equal to 0, and g prime of x is equal to 1 divided by f prime of g of x as long as that denominator is not equal to 0. So let's talk about how we can use this. We have f of x equals x squared minus 2x, where x is greater than or equal to 1. And if you needed a graph of this roughly, you would see that it is a parabola, and so it would look something like this. Okay, so it is 1 to 1. It does have an inverse because we're only looking at the graph where x is greater than or equal to 1. So 3p in the graph of f inverse, because we're looking for the value of f inverse of x when x equals 3, is going to correspond to the point P3 in the graph of f. So if I don't want to find f inverse, because this one would be kind of messy to find, I'm actually going to find f of p, or I'm going to find p where f of p is equal to 3. And this just sets up a quadratic equation that I can solve. And I can factor p minus 3 times p plus 1. So I get p equals 3 and p equals negative 1. And we can rule this one out because it's not in the domain. So this tells me that this has to be the p that I'm looking for. So f inverse of 3 has to be equal to 3. Now it's just a coincidence that they're the same thing. So if I want to find the value of f inverse prime of x when x is equal to 3, according to this formula here, f inverse prime, so notice they've got that in parentheses because it's the derivative of f inverse, is going to be 1 divided by f prime of f inverse of x. Okay, so f inverse prime of 3 would be 1 divided by f prime of f inverse of 3, which is 1 divided by f prime of 3. And f prime of x is actually pretty easy to find here. F prime of x is going to be 2x minus 2. So this is just 1 divided by 2 times 3 minus 2, or 1 divided by 4. So the answer here is that f inverse prime of x is equal to 1 divided by 4. Now I said earlier that a function and its inverse would have reciprocal slopes. So let's kind of illustrate that. This is a simple one. This is f of x equals 3x plus 5. And we know that the slope of this is going to be 3 because it's a straight line. But let's use this formula. We want to know what is the value of f inverse of x when x equals negative 2. So we're saying f inverse is going to be some point negative 2p. F would have the opposite, p negative 2. So without ever actually finding the inverse, I have 3p plus 5 equals negative 2. And if I solve this, I get that P is equal to negative 7/3. So that tells me that F inverse of negative 2 is equal to negative 7/3. Okay. We also know that F inverse prime of negative 2 would be 1 over F prime of F inverse of negative 2, which would be 1 over F prime of negative 7/3. And F prime here, if F of x was 3x plus 5, F prime is going to be 3. So no matter what the P was, this ends up being 1/3. So yes, you could have just found the inverse of that one pretty easily, but it just kind of illustrates the point. So notice that F and F inverse are going to have reciprocal slopes. Now here's an example of one that you would more practically want to use this for. This says f of x equals 1/4 x cubed plus x minus 1. Finding the inverse of this would be very challenging because you would have to know some mechanism for solving for a polynomial of degree 3. It tells us that f inverse of 3 is equal to 2. So what that means really is that if you plug 2 in here, you would get a 3. We want to find the value of f inverse prime of 3. So I know I'm going to need f prime of x, which is going to be 3/4 x squared plus 1. So f inverse prime of 3 is going to be 1 over f prime evaluated at f inverse of 3, which is 1 over f prime of 2. And we know that that's going to be 3/4 times 2 squared plus 1, which is 1 over 3/4 times 4 plus 1, which is 1 over 3 plus 1, which happens to be 1 over 4. So that would be my answer there.